Okay, this video is about key features of exponential graphs. So we've done a lot of parent functions, so now we're learning a new graph. The problem with this one is that the base can always change. So they're going to have the same shape, but you can't just memorize the points and shift them around because why do the 2x's one and why do the 3x's another and why do the 1/2 is another one? But they're all going to have some general patterns and shapes to them. But the way we're going to get the points for this one is to use our graphing calculator. So this is a graphing calculator required activity. All right, so we have our exponential functions, and the exponential function is this right here. Now, what we've done prior to today was y equals x squared, where we knew what the exponent was. Now we're doing ones where we don't know where the exponent is, and the exponent is our variable. So that's what we're working on today. When this is the case in these problems, a and b are always going to be constants, meaning that they're going to be numbers. Okay. There's also some rules about a and b. A cannot equal 0, which makes sense because if a was 0, 0 times anything is 0, and then you don't have an equation. It just all goes away. Okay. The other thing is b has to be greater than 0. So b can't be negative, but a, it can easily be -1. And if I have -1 times 3 to the x, well, that's just -3 to the x, right? So this 1 may not appear, but it's the a itself that's negative, not the b. And the last thing that we have for b is that b cannot equal 1, because any 1 to any power is just 1. So if b was 1, we wouldn't get anywhere. You just keep getting the same number over and over again. So that doesn't work. Okay, when we do these exponential graphs, they will always contain the point 0, 1. Now, I say this as a disclaimer. Okay, yes, they contain this point 0, 1, but that's for the parent function. But then that 0, 1 is going to get moved if this graph should shift. But think about this. If I have, let's say my b was 7. If I have 7 to the 0 power, that's just 1. Or if I have 8 to the 0 power, that's just 1. Any number raised to the 0 power is 1. Okay, so when I plug in 0 for x, up here, anything to the 0 power, I'm just going to get 1 for my answer. So that's why it contains this point. The other thing is that the x-axis will always be, is always an, bad grammar, asymptote. Okay. The x-axis is always an asymptote. And if we remember, we've talked about asymptotes before. Asymptotes are going to be when the graph gets really, really, really close, but doesn't touch. And when you look at these in your calculator, it's going to look like it does touch. And that's because your calculator can't make it work and fine tune it enough, but it comes really, really close, but doesn't actually touch that. And we look at some of the points, we'll see that that is true. Okay, there's two different options. If b right over here is greater than 1, then it's going to be exponential growth. Okay, and your graph will increase. But if b is between 0 and 1, meaning it's a fraction, 1/2, 1/3, so forth and so on, okay, then it's going to be exponential decay, meaning that it's going to decrease. If I can spell. There we go. All right, so we are going to look at these graphs and see if we can plot them. Now, I understand that on the paper copy of this, the grid doesn't print perfectly, but since we're not having to really count points, we're being told what they are, I think we can kind of fudge it well enough to make it work. Okay, so now you're going to grab your calculator and we're going to go to the y equals and we're going to graph 2 to the x. So we have 2, and then we do the caret button and then the x button. So it looks like that. And we want to make sure the x is in the exponent. And we don't know what our graph was set up before, so we're going to go to the zoom and we want the standard 6 by 6, or excuse me, the standard 10 by 10, which is button 6. So I'll hit that. And then you can see our graph. And because 2 is greater than 1, you can see this graph is exponential growth, because as we go left to right, our graph goes up and up and up and then spikes up. So it goes up really slowly and then all of a sudden comes up really fast. Now, I said that x-axis was the asymptote, and you can see on the graph, it actually looks like it's touching it, but it doesn't. It gets really, really close, like 0.000000001, but not 0. It doesn't actually touch it where y is 0. And we also see that if you plug in 0 for x, you get 1 for y. It crosses that point just like I said I would. Now, that point obviously is easy to plot, and you probably should plot that on your graph. But what about some other points? Well, the way we're going to do that is we're going to look at the table. So if you see above the graph button, it says table in blue up here in the very top right corner. So we're going to hit second and then table. And now it's going to give you your points. It's all there for you. You don't have to think. I would like you to do at least 4 points, but if others fit, you certainly could do that easily. Okay, so let's start with some easy ones. 0, 1. Whoops. Let's go to the right screen. 0, 1. And I'm going to zoom this in for a second. 0, 1 would be right there. And then let's see, we have 1, 2. I can keep going back. Oh, geez. I should have put my glasses on to graph this. 0, 1, 1, 2. When we plug in 2, well, think about that. That's 2 raised to the second power, which would be 4. So we've got 2, 4. Let's get one that's closer to the x-axis. What happens if we put a -1? We get 0.5. Well, that's going to be between, oh gosh, 0 and over here. So our graph is going to look like that. Okay, so now we need to identify some certain points on here. The domain, well, as we go from left to right, the graph is going to go all the way to the left and all the way to the right. And so our domain is going to be all real numbers. And you'll find that to be true for all of our exponential graphs. The range, as we go bottom to up, nothing, 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 we're going to say it starts at 0 because it's going to get really, really close. But remember, this parentheses means it gets really close but doesn't actually touch. So it's going to go 0 all the way to infinity. The y-intercept, well, the y-intercept is when x is 0. So the y-intercept is here, right where it crosses the y-axis. And so that point would be 0, 1. And we're done. Okay, so that was, sorry, keeps jumping all around. That was y equals 2x. Now let's try 3x. So we're going to go back to our calculator. We're going to go to the y equals. We're going to clear out what's there. And we have 3 to the x power. And now we already set our window at 10 by 10, so we can just hit graph. And now it still has the asymptote. It still goes through 0, 1, but it actually goes up a little bit faster. It's hard to tell in this picture, but when we see some points, we can do that. So remember, to get those points, we went to the table. So we do second table, and then we've got some values. They're different, but that's okay. So now if we plot them on the graph, if I blow them up bigger, we have 0, 1. 3 to the first power is 3. 3 to the second power is 9. Okay, 3 to the -1 would be was 1/3. And so this is your graph here. Now, I just knew these points, but you're sitting there with the calculator next to you in your graph. So just read them. I'm plotting the point 1, 3. So I go 1 on the x, 3 on the y, 2 on the x, 9 on the y. Remember, x is left and right, y is up and down. Okay, now that we see this, our domain goes from left to right. So our domain is going to be all real numbers. Our range goes from the bottom up, so we have nothing, and it starts at 0 and it never starts growing up, so it goes from 0 to infinity. The y-intercept is right here where it crosses the y-axis, and it's at the point 0, 1. Okay. Try the next one. Okay, let's see what happens when we put a negative in front of it. How is that going to change our graph? Okay, so go back to your calculator, go to the y equals, clear that out. So we have a -2 to the x power. So we're going to hit the graph button so we can see what happens. So it's still got that x asymptote, but look what happens now. Oh, It's flipped upside down, which is exactly what we think should be happening because the negative in front is a reflection. Okay, let's go to our table and see if we can find some points. So in our table, we've got some points. So we'll go ahead and plot them. So as I'm plotting these points, now I've got 0, -1, and 2 to the first power is 2, and 2 to the second power is 4, 2 to the third power is 8, and then we've got the 1/2, and we can easily see our graph just like this. Okay, so our domain, as we go from left to right, our domain is going to be all real numbers. Our range, as we go from bottom up, we have nothing, or instead of having nothing and then starting at 0, this time it starts way down low at -infinity, but it stops at 0. Because remember, an asymptote means it's going to get really close but not actually touch. That's why we have the parentheses. This time, the y-intercept, where it crosses the y-axis, is right there, but this time it's not at 0, 1, it's at 0, -1. And because it's a reflection, that makes sense. Okay, let's see if we can graph the next one. So I'm going to go to my calculator, the y equals, clear out's there. Remember, for the negative, you have to use the negative button and not the minus. So we have -3 to the x power. Go to graph so we can see it. And it's just like the second one that we did on the front, except it's going down this time. Okay, so now go to our graph. Okay, so now we've got 0, -1, 1 to the third, 3 squared is 9, 3 cubed is 27. Doesn't exactly fit, but we can do this one. And now it approaches this way. Okay, so our domain on all of these is going to be -infinity to infinity. And the range is going to go from the bottom up. So it starts down low at -infinity and stops at 0. When you're doing these, you always have to read them from the bottom up. All right. Well, everything that we've done here, even though this is a reflection, it technically is exponential growth, okay? Because the number right here, this number right here is greater than 1. But now I have a decimal. Now it's between 0 and 1. So this is going to be decay. So let's see what happens when it is decay. So we're going to go to our calculator, go to the y equals, clear out what's there. And I've got 0.5 raised. Don't forget your decimal point, makes a big difference, raised to the x power. So let's see what a decay looks like. So we're going to look at our graph. And here comes our graph. It comes in and look, it still approaches the x-axis. That's still an asymptote. It still crosses at the point 0, 1. But this one, as we go from left to right, instead of it going up, now as we go from left to right, this one is decreasing, and that's what makes it exponential decay. All right, so we're going to go to our graph. Well, whoops. Let's go to our table first. So second table, and now we have some points. So if we graph them, we've got, can't use the highlighter. We've got 0, 1, -1, 2, -2, 4, -3, 9, 1/2. Again, I know these points because I've done them so many times, but you're literally looking at the table, plotting those points onto your graph. So you're not memorizing anything, you're just copying the numbers down. So the domain on all of this is -infinity to infinity. The range, we go from the bottom up, so it starts at 0. So it goes from 0 to infinity. And this one, it crosses the y axis at the point 0, 1. Now, over the coming days, we're going to look at some other ones of these and we're going to shift it up and down. And then that's going to change. But today, as we learn the basic ones, we're going to keep it pretty straightforward. Okay, so you can probably guess then what the last one is going to look like. It's going to be this graph over here on the left, flipped upside down. So we'll go to our calculator. We'll go to our y equals. We'll clear this out, and I'm going to have negative 0.5 raised to the x power. You can hit graph and see if our prediction is right. Is this graph flipped over? It most certainly is. It's still approaching the x-axis, so the x-axis is still the asymptote, crosses at 0, -1. Okay, so it's just like we thought would happen. So now we can plot those points. So I've got 0, -1, -1, 2, -2, 4, -3, -9, 1, -0.5. And there is our graph. So the domain for all of these is all real numbers, but the range, we have to start from the bottom up. So it's going to start at -infinity and stop at 0. My y-intercept is 0, -1.